So when we look here at reference table M, we're looking for phenolphthalein, which is right here. And we want to know what the color of phenolphthalein is in a base, like sodium hydroxide. So a base's pH is 7 and higher. So we're looking for the higher pHs. We notice that the higher pHs, which would be to the right of the number line, will have the color to the right, or pink. That makes this choice our best answer. In questions 15 and 16, we're dealing with a titration, so we're going to refer to the titration equation from reference table T. Now looking at the problem, let's see what information we can identify. So here we're told that the hydrochloric acid has a set molarity. This is going to be our MA. Now we need to find the volume of acid, but here we're given 2 volumes. Let's deal with that in a minute. And for the molarity of the base, we look here and we see that it is unknown. So that is our X. And then again we have 2 volumes for the base. Now we have to remember that we're dealing with a burette. A burette again is an upside down graduated cylinder. To find the volume of the acid and base, we're simply going to find the difference between the 2 volume values. The number that my calculator gives for this correct numerical setup is 0.1998. Now, when in Regents chemistry, we usually round to 2 or 3 decimal places. Now, we always round to the correct number of significant digits. Notice that the least number of significant digits is represented by this value here, which only has 2 significant digits. So our answer should only have 2 significant digits. That means that we're only going to have 2 place values, but we must refer to the 3rd place value to determine the second. So this would end up rounding to 2/10 of a molar. I will keep the 0 to indicate its significance. Here we have another reading comprehension question, and we're concerned with the pond. So we notice that a pond has acid spilled into it, and it says, name the ion that is increased in the pond due to the spill. So here we have to look at acids. Let's look at our reference table. So we'll examine our common acids table and realize that acids have this H or hydrogen ion in common. So the acid must add hydrogen ion. The next question refers to pH. So again, we should draw our handy dandy pH square. So the reading tells us that the solution was originally a pH of 8. And then acid was added to it. So now the pond is 1,000 times more acidic. Acid is going towards the left. So we want 1,000 times more acidic. Well, the value of 1,000 can be written as 10 to the 3rd power, which means that we're going to have to move our pH 3 units. So 8 to 7 is 1, 6, 5. So our new concentration will be a pH of 5. The next question has us discussing the color of an indicator. So again, we're going to use reference table M. On reference table M, we're going to want to find the indicator in question, which is bromothiamyl blue. And we want to know what the color of the indicator will be in the new pH. The new pH is 5. Looking at the pH range, 5 falls to the left of the range, meaning it's going to be the left color, making bromothiamyl blue yellow. Now, the next question refers to a water solution that conducts electricity, meaning it is an electrolyte. The only substances that are electrolytes are acids, bases, and salts. So And the next clue is it turns phenolphthalein pink. Referring to reference table M, we're going to find phenolphthalein. Phenolphthalein is here, and if the color is pink, we're going to notice that it's going to be, since pink is the rightmost color, it's going to have the rightmost pH or higher. So at a pH of 9 or higher, you would expect a base. So then we're going to refer to reference table K and L to see if we can locate the formula of a base. Here we're going to look under the common bases, and again you'll notice that sodium hydroxide is a common base, which is choice 2. The next question has us referring to reference table J. So we want to know which of these metals would react readily with hydrochloric acid. Here is the acid. So we want to find the metals in question. They include the elements that I've circled. So we want to know the one that is going to react the most. So if we're going to go and have something react the most, we're going to look for the highest element on reference table J, which is potassium. In the next question, we'll notice that we observe the key word titration. The first question asks us to calculate. So all calculation equations are found on reference table T. So now let's see what information we can determine. So from the question, they give us that we used 1.2 molar HCl. That's the molarity of our acid. Let's continue and see what other information we can find. Here we see that we have 10 milliliters of hydrochloric acid. That's our volume of our acid. Now, reading back into the question, it tells us that this titration was used to find the unknown molar concentration